In this video, we are going to introduce the concept of generics. How would you define a pair of two integers? Well, here we see a possibility. It's very easy. We define two attributes of type int, and then we define a constructor and the typical setter and getter methods. But imagine that some other day you had to define a pair of strings. Then we would proceed in a very similar way. And on some other occasion, you would need a pair of a string and an integer. Again, the same idea. Only the classes of the attributes change. Now, with these three definitions, you could define objects as you see here. II is a pair of integers, SI a pair of a string and an integer, SS a pair of strings. And we could get the first components of each pair by using the appropriate getter method, get1. But this procedure really doesn't scale. If every time we needed a pair of something, it's too tiresome to define a similar class. Fortunately, there's class object, which is a superclass of all classes. So you can define two attributes of class object, say 1 and 2. This is the most general way we can proceed. With this more general definition, we can define a pair II of integers. Int values are objects of class integer through boxing, and therefore they are also of class object. And you could define a pair SI with the first object of class string and a second an integer. And the third pair SS with two strings, all with the same definition pair that uses objects. The problem comes when we try to assign, for instance, the first component of the pair to a variable. What happens if you write string s equals get1ss? The compiler would give an error because an explicit cast is necessary. Is there a way to improve the situation? Well, it would be nice if we could have type parameters. In the same way as a method is a statement that has parameters in it, a generic class has type parameters in it. In this example, A and B are type parameters, or generic types. They represent any concrete type, but at the moment we don't specify which one it is. Now you can define pairs of concrete types. II is a pair of integers, SS a pair of strings, because you declare them like this. Note that when you want to create an object, you may rely on type inference using the empty angular brackets. This is also called the diamond operator because of the form it creates. So we have some parallelism here. On the level of values, we have values like 1 or 2, and we have variables that can hold different values at different moments. And when we define a method, we allow the input to be variable and compute the result depending on the values of these variables. Now we have seen a way to generate classes that are of the same structure, but depend on some types. And for the definition, we use variables for types or generic types. The result will be a class that depends on the concrete types given.